Okay, let's start with a silly example. Here's your graph. We are talking about work and home, and we're rating it whether it's good or bad. Various locations. Okay, so let's look at graph F. Person who says graph F says that work is okay, home is great, and as this person goes from work to home, life just keeps getting better and better. As they drive away from work, it just gets better the further away from work they get. Now let's look at a different person's situation. Look at this graph. This person's work sucks. Very, very bad when they're at work, and at the exact moment that they leave work, instantaneously, as soon as they get in their car, things get a whole lot better. This is called a jump discontinuity. G is not continuous at work. It jumps up. This is a removable discontinuity. We could move that dot up to that little open hole up there, but as it stands right now, it's discontinuous at that point. How about another graph? This person has a totally different feeling. Person whose graph is H says that at work, things are a little bit better than okay, and at home, things are a little bit less than great. But H hates driving. As soon as H gets out of work, things are terrible, things are pretty much bad, and stay bad until they get home. H has a discontinuity at work and at home. Now, if we want to make this a little bit easier to understand, we can put values in it. Maybe you live 20 miles from home, and the X value is how many miles from work are you? Okay? And we could put some numbers on the scale. Okay is good, great is 3, and bad is -1, awful is -3. So in this case, we can look at the graph and we can pull some information out. F of 0. I know the axis should be 0, but what the heck? I say 0 is here, 0 is there. F of 0 is 1. That is the value of 0. F of 0 is 1, and do another one. G of 10. We go, it's this point. This is how this graph, this blue line, tells us about G. And you go up, it's like, oh, what, 2.7. Fine. 2.7 is approximately, maybe it's a little higher than that. Whatever. Okay, what else have we got? The domain of all three of these graphs is everything from 0 to 20. There's no points above anything less than 0. There's no points above anything greater than 20. But all the way. Now, even though H has these holes, at 0 there is a point. It's up here. And that's kind of interesting. F is entirely continuous and increasing from left to right. G is also increasing. Well, we're not going to talk about what G is doing at 0 because it's got this weird jump, but otherwise it's increasing. They all have the same domain. G and H have removable discontinuities at 0. I've talked about this. So that's enough for this graph.